how you wanted it, if it was from an electronic copy or a paper copy, if you put paper reference and then electronic reference.
I worked on
Like P&E.
oh, for the paper.
We were over the standard.
No, because that's still page on your.
Okay, and that's what we didn't go over a whole lot. Could you, okay. Now it's still built in.
I was like, she mentioned something like 2 classes ago about putting
What do we need to do?
sit there and follow around if you have.
Do what? Everything else. So we have all the standards done, we just don't have,
I think we don't have the students done.
we don't? We do have.
We made that.
Keep processing the question.
I know, right?
How we learn.
I was gonna say, you know, you and I have like the
Yeah,
same
yeah.
amount of knowledge here, right?
We spend more one time.
So what is that difference?
Very
from-
true.
You said you do, her more person, not the content, but more person.
Yes, I do.
Oh, really? Oh, okay. Yeah, that's me too. Yes.
I'll show you only have, you have only 2 evidence.
I was playing, well, I was playing. You saw me doing that?
So what you might want to do,
That's why I don't. That's smart.
I just got
Well, not
confused
bad.
when they started doing stuff. Oh, he did this.
Oh,
Like,
yeah.
it was
Like,
confusing.
we won.
And then I felt guilty for about 15 minutes.
I think as long as the snacks are healthy. This is the last day.
it's fine.
Why's that?
I've been drinking too many of them.
Yeah, I know when I get to
I
that
don't know, I
point,
had
I
like an
stop.
awful experience once in my life, and like since then, like I'm usually like the person who's like, we're doing all this, like.
I need to use the level.
Oh, gosh.
Well, they're going to be using
And then we
ratios.
teach on Wednesday. So we have like.
Okay, guys, here's a question that you need to hear the conversation. So, this team said they didn't write down the math because, whatever reason, okay. But if you're talking about, okay, so if you're talking,
And I work, or I work weekly, so.
right, so if you're talking about the formation of a new substance, if you just use water, those are ratios. You see numbers in there? Okay, this has a math component to it. So that's where you would go back and look at the math sheets for ratios or proportionalities. The new math sheets. And I'm thinking, Ruby, that the ones they have are not the new math sheets. We need to check that out. They'll be online, huh? What?
She's asking about the teeth.
The math sheets, the new math sheets will be online. I need to look at the date on those ones that we gave you. I think those are the old ones. I don't think they're the new ones. So we need to see if we have the new ones.
New math team?
We have the math standards.
What does it say? What grade level? Huh?
We don't have the math sheets.
Oh, you don't have the math sheets?
We just have
Well, it'd be hard for me to look at them then, wouldn't
We
it?
have the
See if they're
standards.
old or new. Huh?
So Dr. West, do they need the math sheets? Should I get them now?
Mm-hmm.
Okay. Middle school, right?
No, elementary and middle school.
Checks this for me during the
Yeah.
day.
That's nice.
So we
Can you
don't need
figure out what that
to.
phone call list is? That
Does that count?
This is CCRS.
Which is fine.
No.
Are you doing good?
Gotcha.
Are you doing good?
Okay, Tyler asked a question that's good. Do you look at the math standards in CCRS? No, not at this level. If you were looking at a high school course, then you would, because you know, you have to begin with the end in mind, which would be CCRS, and work backwards. So ideally, you would want to, but initially, you're going to start with what's nearest to you. So the thing that's nearest to you is going to be elementary and middle school. Because the math that's needed for the science has to be learned before they have it, before they have used the math in science. The math has to be learned in the math class before math is used in the science class.
Is this still incorporating math though? And I don't.
You see numbers up there?
Well,
If you see numbers, it's got math in it.
yes, but it's just, but it was asking for evidence such as just color change or change in temperature. Why?
Okay, I see what you're talking about.
Yeah, why would-
Okay, so are you at some point going to write an equation that illustrates that?
No.
How do you know?
Because they're just looking at evidence of what could possibly be a chemical reaction or a physical change. Or
Okay, but are you ever going to get any kind of equation out of it? So, it depends on your activity. I would say you're probably right that you would not at this point, but at some point you will during the strand, you have to. Okay, go ahead.
Okay, well,
So our TEACS is identify the formation of a new substance by using the evidence of a possible chemical change such as production of a gas or change in temperature. I'm not quite sure what exactly to talk about with it.
Well,
we didn't really
what did we
get
say
that
for the first lesson? What are some of the early things that you would do when you're thinking about trying to plan a lesson around a TEAC?
I think the first thing we thought about was examples of a chemical reaction.
Okay,
And we thought about physical changes and chemical changes and the
Mhm.
differences between them.
when are physical changes taught, learned?
I'm maybe.
What grade level?
I put TEACS 5.5A.
Okay, so 5th grade.
Yeah, and it says classify matter based on physical properties, including mass, magnitudes, and physical state. solid,
Now,
liquid,
mass
gas,
is gonna be
and-
gone from the new TEACS.
Okay.
Mhm.
But yeah.
fifth grade, so they should have a basis of what a physical change looks like. And we would talk about how we would go back over it and our example would be like ripping a piece of paper, what kind of change was it?
How would they know? What other kind of questions should you ask with something like that?
It doesn't change the substance.
How about starting with what it is to begin with? What is this? Is this paper?
Okay.
Agree. Now what happens if I rip it in half? What are these pieces? Still paper. And what if I wad it up? Is it still paper? Now, what's the problem with using paper as an example?
Like, I feel like maybe it's not really, they wouldn't associate.
It's not really a chemical. I mean, they can't
Yeah,
really,
it's not, you really don't really associate.
so you're kind of giving them a general idea, but then you've got to get more specific to what you're looking at here about chemicals.
I was thinking more like water and ice.
Water and what?
Ice
What do you guys have, 5th grade?
For a phase
or
change,
physical change.
that would certainly be one. Okay, so some examples like that. So in reality, you're probably going to have to go back and review physical changes before you ever get to this one. But y'all are not going to do that.
And then we went ahead and talked about how,
Let me see that. I want to see the date on it.
we wrote down standards from each of the standards, and I think that's as far as we got. We didn't get super far.
Yeah, we didn't get
Well,
to.
probably your standards shouldn't be too much different than Team 1's.
Right.
Right.
It's just,
So what would be some examples, common examples that the students might understand about gas production or a change in temperature?
I feel like maybe gas production, maybe like boiling water or something like that, but for a fire, something like that.
What is boiling water? Is there a chemical change in boiling
No,
water?
but like the gas part of it, they might see the gas, see steam coming off the water.
We would identify that later as a misconception.
Yeah,
But not to be listening. We're talking about vinegar and baking soda,
Mm-hmm,
and the bubbles that are produced from that,
okay.
to identify that as gas.
Mhm.
I think
How would they know it's a gas besides, are they gonna equate the bubbles with the gas?
I'm not, you'd have to kind of explain that the gas is inside the bubbles and it's, when they pop, it goes up in the air.
If you do that in a Ziploc,
I'm not eating it.
they can see it blow up like a balloon. So they might infer that it's the gas that's being produced.
Mhm.
Okay.
Good idea.
Okay,
We also thought, well, we wouldn't do it like in a school, but lighting a match, and that's a chemical reaction because there's heat and there's light.
what evidence does the student have? Actually, you can do it at school. You could have students do it at school if you have control over the students. So they actually will be more engaged with it if they're lighting the match.
that's true.
Okay,
But yeah, it would go along with what we have because there's production of gas, so the smoke, and then the change in temperature, it's hot, so.
okay, what are some misconceptions about something burning?
Well, I think it didn't have anything to do in the standards or anything, I was just.
I think it did in the chapter 15 and benchmarks in the benchmarks.
But like whenever you're burning wood or burning a match, there's like a change in how much it weighs, but there's not.
Can the students do that?
I guess so.
I don't think so.
No,
Mm.
because you'd have to burn the
You'd
match
have to
in
have,
some
I would think,
closed container.
a balance is, pretty fine tuned, so to speak. And that would be like an electronic balance, and you're not gonna be having those in middle school.
Yeah.
So what you have to focus on initially is what can students do hands-on that's going to give them the experience. So you can tell them that burning wood is a chemical change, but that's just telling them. So what kind of experiences can you give them that they're going to learn the characteristics of possible chemical change? First of all, what's a chemical change? What do your teaks say?
When something is, there's a new formation of a new substance.
Formation of a new substance. So that's the first thing that you have to help them understand, that it's new. So how do you know it's new? Well, we assume it's new because gas is produced. And what's left over is new because gas was produced. It was given off, so it's no longer part of what they have. Or the temperature changes. Have you done the baking soda and vinegar?
Yeah,
What did you see with that?
it foams up really fast.
And,
It expands.
Yeah.
and,
Well, they use it in little volcanoes and stuff.
well, no, but what did you observe with it besides gas production?
Well, I haven't really done it since maybe I was in elementary school.
Okay, then guess
Yeah.
what? You need to do those activities. I want you to put it in a Ziploc bag and I want you to hold it. Okay? All right, what else? How far else have you gotten in there in terms of examples?
Well, there are glow sticks and hand warmers. You could bring it like a hand warmer
Mhm.
and tell
Like
them.
we have in one of our boxes back here.
Yeah, and you can tell them when you it pops something that's inside, and then the chemical is released, and then there's a chemical reaction inside the bag that makes it warm.
Okay, what has to come first?
The concrete.
Okay, so you're not telling them anything first, so they have to have
You
the
just
concrete physical experience with it first.
would you tell them to pop it or?
Well, whatever the actions need to occur, that's what you have to tell them. But then they have to make observations about what happens as a result of those actions. So you're going to give them directions to do this and do that, or don't do this and don't do that, or put this together and that together and observe what happens. So you're not telling them what's going to happen, because they have to go through that concrete experience, and they are learning the pattern. They're learning about the results of things that you're going to tell them to do. Okay, so you can't tell them what's going to happen. You can't tell them that wood's going to burn, because how are they going to know? What evidence can you provide? Can they see that that burning wood produces a new substance? And you're going to go to benchmarks for science literacy in chapter 15 and see what the misconceptions are. Okay, because there is a specific one in there about wood burning. Okay, so anything else?
I think that's.
No, I think that's it.
Okay, team 3? Well, colleagues, did you have any recommendations for them? You remember, this is collaborative planning here.
Serve milk and lemon juice.
Milk and lemon juice? Why would you want to put milk and lemon juice together?
Curdled milk.
Curdled milk, that's right.
Well, it makes
Ever heard of clabber milk or buttermilk?
Yeah, it makes buttermilk,
Uh-huh.
which is something your students might have in their kitchen, so.
I don't know, not many people have that these days. There's buttermilk biscuits though, they may have heard that.
Buttermilk
There's some
pancakes.
restaurants, yeah, buttermilk pancakes. So what about some boxes, probably you don't have time to do that now, but as you're teaching, that you would have not necessarily the whole box, but at least the cover, the front part of it, and to use as examples of how, I guess, people have made money off of knowing certain things.
Do you know when Jennifer's gonna do that, cause she's my
Probably
partner?
more.
Yeah, she should have been contacting you.
or-
She said that she has been keeping up with everything,
Okay,
and that y'all could use Google Docs to work together,
okay,
so you should contact each other.
okay.
And apparently she's coughing a lot, but she keeps a cough drop in her mouth, so
Okay.
certainly, this one.
I'll call her, yeah.
Okay, so what kind of examples did you guys come up with?
For our content?
Your teaks?
Okay, so we discussed using Coca-Cola and milk to show formation of precipitates. We also discussed using lemon juice and milk to curdle the milk, like you were saying. That's for the precipitate specifically.
What does Coca-Cola and milk do?
It's the same thing, basically.
Huh?
Same thing, basically, it just takes longer.
It
Yeah.
takes longer.
Okay. What would be some activities or examples that kids would be familiar with?
As far as like
Which ones,
precipitate,
your includes
precipitation.
precipitate and that should be a permanent color, because
Yeah.
what would students think of if you just say color change?
It'll go back.
Like any.
What would be an example though that kids might experience?
Like a mood ring?
Pardon?
Like a mood ring? Is that what you're talking about?
A mood ring? I hadn't thought about that. I was thinking about something like Kool-Aid or
Oh.
food coloring.
Yeah.
You can just, you got water and then you put it in there.
We had discussed a non-example,
Precipitate.
a non-example for the color change, something that's a temporary color change would be those cups that you get that will change color when you put cold water into it, and then once the
Oh.
cold water's out, it'll turn back to the
Okay.
clear color or whatever color it was before.
Okay. Either one of you have one of those?
Yes, I have several.
Okay.
That's why I
Yeah,
thought
I
of
have a
that.
couple, yeah.
I know, you gotta have stuff to teach science with, so you need to start collecting stuff now.
Well, and we talked about,
So we talked about examples and non-examples
Yeah.
of precipitate and of
So-
the color change.
so for a non-example of precipitate, we talked about taking lemonade and putting more sugar in it because the sugar won't like dissolve after a certain point, and asking, is this a precipitate or is it not a precipitate?
Oh, that's tricky.
What's the substance at the bottom?
Yeah.
That white substance at the bottom.
Uh-huh.
And then for
That might be a good assessment, right?
and what
Except
else?
you're not doing evaluation yet. But you could still use it
Mhm.
as a question during your discussion
Mhm.
to determine if they really understand the concept, yeah.
And for things like the permanent color change, we talked about the glow stick, breaking a glow stick. Something that would be used, maybe not in the explore, but during the explain as an example, would be leaves that have changed color or leaves at different stages of changing color. That may be a little beyond, the science behind it may be a little beyond their level of understanding, but
Well,
it's
it's
something
kind of
that
a
they would be
nice
familiar
example,
with.
yeah. But something, guys, that you all of you need to remember is that, for example, if you use the color change, leaves that have changed color, you need to know the chemistry behind it. You need to know all about it, even though it's not gonna be taught in the lesson.
Interesting, okay.
Because of two reasons. One is you don't make a mistake when you simplify it, because you have to know a lot more to simplify something than not. And the other one is that if somebody asks a question and you can come up with a quick, short answer, or, you know, tell them that you'll talk to them about it during advisory or something like that. So you need to know a lot more than you teach.
That makes sense.
Okay, what else?
I actually had a question about something I had been thinking about, which would be burning something, like
Uh-huh.
burning wood. So there's a color change that's happening there
Mm-hmm.
with the ash, but is that reaching?
The
Too much
ash
for the color change?
or the wood as it burns, that's what
Like
I
the
was thinking
charred
about when you
burns.
mentioned it. What? You think about the wood as it burns, Elston?
That's what I thought you meant. I don't know, this
Is that something that's reaching too far though? Trying to demonstrate the
I
color
actually think that'd
change
be a good idea,
when wood burns.
because that goes to a lot of other chemical changes as well.
Well, I think it's probably too complex, but if the lesson before it, that they developed a clear understanding of what a chemical reaction is, or evidence of a chemical reaction with the precipitate or the gas, maybe so. But that's really edgy.
Okay.
Yeah. I think I'd try something more simple and more obvious, especially to begin with. And you've only got 20 minutes, so, you know, with this kind of lesson, you can't really have a lot of examples. So
Other
do
things-
ones that are simple and very clear,
Yeah, and we
cut
talked
to the
about
chase.
food changing colors, apples changing colors,
Yeah,
bananas,
apples,
avocados.
bananas. Avocados was a big one.
Because that one happens really quickly.
Yeah.
Well, you
As
could
soon as
even,
you cut open an avocado.
Well, sometimes, I mean, there are avocados that don't. We've had, you've been in here, we've had
Well-
students that have used that, and they thought the avocado was gonna change color quickly, and it doesn't end up changing color. So this is one of those times when you might want to pre-record it, so you have it in case it doesn't work
Like a timeline.
at school, that you're gonna pre-record it at home with the apple, with the banana, with the avocado.
what about with what she's saying with burning? What if you burn like a white piece of paper? Because that's a very obvious color change. Like you don't like burn it, but you know, you char it, or not char, that's not the right word, but you're using the fire to quickly change the color. You're not having to burn an entire piece of wood, and then it's going from white to that yellowish brown
That's
color.
an interesting idea, I hadn't thought
And then
about
you
that
can
one.
even, non-example, do like a staining it with tea, because stain is not, doesn't have to be.
Okay, and that's also a good idea to have non-examples in there. Sometimes non-examples help you understand a concept better than an example will. So write all those down, and then you'll have to decide which ones are gonna be the best ones for you to use with a short lesson.
Yeah.
Yeah. Good thinking, good. Any other questions? Not now? Okay, next team.
Are we still bringing up things under the document?
Is the doc camera?
Yeah, do we need to?
No,
Or are we just
I mean,
talking
it's
about
your
it?
choice.
Good.
You have it written out that you would put on, print it out, so you
No, I
put
was
it on
gonna
the doc camera?
No, I don't.
Okay. Don't forget, you guys can go to the biology computer lab right behind us and print out stuff.
There's gonna be more of like everything in the middle. So, all this is, can you look at this as your sex is? Electrons are an electron cloud, so you have to talk about these. So when that electrons are negative and protons are positive. And then, well, you're not really going to have one, you kind of have to get a model, or you have to like do like a student-led model. Like, have you ever done like a human model, like for people like you have kids stand and like pretend to be like proton. I did that in one of my classes when I was observing, and it worked. I did it for my acting and my own thing, and it went really well.
Does your downloaded fancy and stuff like that?
I don't know, because we were talking about earlier about whether that's concrete. I don't know.
Alright, so our TEKS is 6.6K.
Excuse me, you have to get, secure the attention of your students prior to instruction.
Guys, eyes up here. So by the end of this lesson, our students should be able to compare metals and nonmetals using properties such as luster, conductivity, and malleability. We decided to leave out metalloids. We felt like we could bring in the transition later.
In a later lesson,
Yeah.
because we didn't want to do too many concepts.
Mhm.
For lessons, since we were supposed to do one concept, but we kind of did.
But it worked
two.
out better though to
Yeah.
have two so you can
Have them
compare and
compare.
contrast them, yeah.
Yeah.
So remember, these are not laws.
Just guidelines.
But we did decide to include the vocabulary of luster, conductivity, and malleability because we feel like they know synonyms for those words, so they can kind of formulate their own definitions of those words and then say, well, in science, we actually call
Shiny.
reflect,
Shiny,
yeah,
luster.
shiny, we call it luster. We call bendability malleability, you know.
Good.
So that's what we're highlighting in the TEKS. We just started going through all of the other standards. I suppose you kind of.
Yes.
Okay, great.
Yes.
I looked at the STAR tests and I found maybe 6 items that are relevant to our TEKS as well.
And why don't you think you didn't find any more?
Because, well.
It's only been 3 years of the tests, so maybe. Or maybe
Mm, there's
it's
a more
supporting
important reason than that.
Is it a
Guys, can you help them
supporting
out?
It's a supporting.
Is it supporting?
Yes.
Yes.
What grade level is the test given?
8.
8.
What grade level is this?
6.
That's right. So you're gonna have, like the NGSS, you're gonna have that kind of summative assessment there. So you're not gonna necessarily, maybe even, not even find one. I don't know if there's any in here that, has anybody not found a STAR item that relates to your TEKS yet? It wouldn't surprise me if you didn't.
When something is not a supportive TEK, would you expect it to be tested? Because on each test,
Tested where?
on the STAR, multiple, like 4, 5 questions, 2 questions. On average, they have 1 question for this TEK.
It may not even be on the STAR at all.
If it's not supportive, if it's
If it's a supporting standard, it may not even be on that STAR.
readiness will be. So,
We only test for it randomly, right?
Yeah, random, the supporting standards are tested randomly.
But we found that this is a supporting standard that they test
Very well.
consistently.
Okay,
Um,
how many did you find?
Let me double check. 1, 2, 3, 4, 5, 6. I found 6.
Really?
And one of them, I mean, they could be sort of reaching, but I feel like with these teaks that we do have overlapping content.
Does the star answer key say 6.6A? That's the teaks that it's tested? I mean, I'm assuming it does, or you wouldn't have known it, but that sounds like a lot.
6 in one test?
Pardon?
Is it about 6 in one test?
6 in
or
all,
on
or
all
like
of them?
what?
I think all three, right?
I looked at all 3. I think there are 4, 2013.
Yeah, there was 4
Oh,
on
Oh
there.
yeah, because they have 16 on
Yeah.
that.
You have 16 on that one. And it does say 6.6A, which is interesting. I didn't realize that. That's awesome.
Oh, you just guessed at the questions that were being asked?
I was just using keywords.
Oh, okay. I was gonna be my question to you in a second. I was like, how did you look those
I
up?
think I mentioned last class that you look at the answer key and it tells you,
This is awesome. So I was using keywords
okay.
like such as property,
Mhm.
malleability,
Probably a lot easier to do it the other way.
elements,
Uh,
and there's smaller documents that I have to download.
Well, good, maybe all this money you pay for
Very
this course is paying off.
Oh man, that's funny.
Don't worry, I did it that way last year. I did it the hard way.
The hard way, you just did.
I'm glad to have that epiphany right now. At the end of the year.
So, do you want us to talk about the standards that we?
What did you learn from the standards? I mean, they've been pretty much the same,
The
so
same,
what have you
yeah.
learned about your particular teaks?
Well, actually, I was looking at the misconceptions in the standards, and there actually weren't many in the benchmarks that I was able to find, but we had come up with on our own.
Did you go online to Google some?
No, I didn't. I just looked at the benchmark.
Remember, that's one of the things you can do. The benchmarks are what, 15, 20 years old? So there's newer research, but as I said, I would Google, this would be one thing that I would kind of trust if I Google it.
Googled it.
Mhm.
We had come up with the fact that since mercury is like a liquid, people think that it's a metal. So maybe that would be one of the misconceptions that students have.
Mhm.
Yeah, we were thinking of exceptions like mercury.
Oh, yeah.
A lot of the STAR questions have to do with the orientation of the elements. So I didn't realize the importance of the students knowing exactly where nonmetals and metals, where the line is on the periodic table.
Ultimately, they do. That's not important initially, because you're not, these teaks are not about the periodic table. They're about building ideas that are in the periodic table so that it ultimately is going to make sense in the 8th grade. So you can have a periodic table at this level and say, after they learn about the characteristics of metals and nonmetals, well, here's a periodic table that you're going to learn about in the 8th grade, and it has all of the elements in it that we know now. And if you look, you will see the periodic table that has these elements that we call metals are all here, and the nonmetals are over here. But that's about the extent you're going to get into the periodic table.
Just to
For
introduce
6th
it to
grade.
them so they see what it looks like.
Yeah, just approximately, and then when you do metalloids, then okay, look here, they're kind of in the middle, so that makes sense. Oid meaning like, similar to.
Should we introduce the topic of metalloids, or should we
No, not
just
in your
leave that?
lesson.
Okay.
No, I'm saying after you
After
would
we've-
do the lesson with metalloids. Now, there is there should be a picture on tracks about material mats. Ruby, do you have that picture?
Some material mats.
Yeah. A material mat you would use, for example, you might take a white piece of paper like this, and you'd have one at each station, and you would draw a diagram that looks like a wire, and so you would say copper wire. And so this, and that's where the students or the teacher initially would put all of those materials, so that when, after the lab is over, all of these materials are cleaned up and they're put back in their place, and it's easy for the teacher to just walk around and see if all the materials are there. And there is a picture of a materials mat, so you need to think about whether or not you're gonna need it for your lesson.
Materials mat. It's like a
M-A-T, materials mat.
right? It's like a murder. Oh, we were also thinking about different elements, not compounds, but just elements that we could use in the classroom. We talked about aluminum. I saw there's sulfur in that box, which is interesting. That's definitely something that we'll have to integrate.
Now, what do you need to know about sulfur?
We need, well, I'm definitely gonna check out the MSDS for it.
SDS now, no
Yes.
more
Oh, really?
MSDS, yeah.
Well, I'm gonna check out the STS for it,
Good,
because I have no idea.
okay.
There are some people who have student allergies to
It's
sulfur.
MSDS, but different.
Well, it actually has some toxicity,
Oh, it does.
so you would need to
Like it
keep
shouldn't be in the
it in a Ziploc.
Well, like Elizabeth last semester, she couldn't touch the sulfur because she's
Oh,
one
yeah.
of those people who's not deathly allergic, but she's very allergic to
Allergic.
it. Like if she touched sulfur, it would like hives. You might,
But she knew it before the
No,
lesson.
that's what I was gonna say, that's kind of a crazy thing to,
and it's not common.
yeah, to come in contact with.
Yeah, it is.
And that's probably part of the safety instruction that you give to kids early in the semester, that, you know, if they touch something and it doesn't feel right or it causes some kind of irritation, they should immediately tell you, not try to hide it or anything.
Trust your intuition.
Where on tracks is that?
I don't know, I'll have to look for it and let
But
you
she's
know.
not- it's not-
I'll tell you what, why don't y'all take a quick break, and I have some pictures I'll bring back and show them to you.
Oh yeah, it is right here, I found it.
What?
Oh, I was looking it up.
Yes, okay, yep, there it is.
Yeah.